Okay, we are starting on chapter 10. Can you believe it? We are going to be focusing on probability and statistics. Good old stats. Now, I went ahead and really rewrote and summarized the notes for you to make it a lot easier to understand. I tried to break it down as much as I could to make it easily explainable. So, as you read through the notes, it is vital, not only just watching this video, but please read through the notes, do the practice problems on the notes. There are questions, and then on the next slide, there are answers. Remember, don't just look at the answers, read through, do the practice, think for yourself, and then there are optional questions from the textbook. You don't have to turn in those questions from the textbook to me. I did post the parent check, so you can do those on your own. From now on, you're not going to be turning those in. I'm just going to be trusting personal accountability, parent accountability. I'm going to need you to check those, and then really the only assessment to make sure that you're understanding will be the quizzes and tests. So please make sure if you're having trouble, you reach out to me, send me an email, send me a Marco Polo. Remember, I'm here to help you. But please, it's vital that you read through these notes and do the practice. The first thing we're going to do is we're going to start very simple. We're going to focus more on a foundational technique, which is going to be creating a tree diagram. Now, the tree diagram shows basic possibilities and arrangements of letters and numbers. So we're going to first start with the letters A, B, C. Okay, so A, B, C. Now, if I want to go ahead and arrange these, okay, with different possibilities, the tree diagram is going to look something like this. Here we have A. A can go with B, and it can also go with C. A can go with C, but it can also go with B. Now here we have B. B can go with A and C this way, or B can go with C and then A. And then I have C. I can do CAB, or I can do CBA. Okay, so that gives me a total of, if I'm dealing with ABC, that's giving me a total of 1 possibility, 2 possibilities. BAC is 3, and BCA is 4, CAB is 5, and CBA is 6. So using the tree diagram, this gives me a total of 6 possibilities. Using the tree diagram now, I'm going to go ahead and take a look at a word problem. This is the first word example on this page, and basically what we have is John is packing for a weekend camping trip. He wants to interchange his clothes so he can have a large variety of arrangements and possibilities of outfits. He's packed pants, he's packed t-shirts, and then he's also packed socks. Now the 3 arrangements for the pants are khakis, jeans, and shorts. The 3 arrangements for the t-shirts are by color: white, red, and green. And for socks, he only packed 2 possibilities, white and black. So he has packed pants, t-shirts, and socks. So basically, we're going to make a tree diagram here. So let's take a look. Let's start with khakis. So I'm going to go ahead and make our little tree diagram. And I'm going to start with, okay, the pants. I'm going to go khakis, jeans, and shorts. Okay, so khakis can be matched up with, I'm going to line up the pants first. We're going to go khakis, jeans, and shorts. So let's give the different arrangements of shirts with khakis: white, red, and green. With jeans, it's also going to be white, red, and green. With socks, scratch that. With shorts, will also be white, red, and green. Okay, with the khakis and white, the 2 possibilities of socks would be white and black. With khakis and red, white and black, with khakis and green, white and black. Okay, so here I have a total of 6 possibilities with khakis. Now, if I do the same thing here with jeans and white shirt, white and black, jeans and red, white and black, jeans and green, white and black. Total of 6 possibilities. Okay, with shorts, white shirt, white socks, black socks. Okay, 1, 2, 3. Okay, so we had 1 possibility here, 2 possibilities there. With shorts and red, white and black, shorts and green shirt, white and black socks, a total of 6 possibilities. So if you're not sure how I got 6 possibilities there, okay, for each one of these, we have khakis, white, and white is 1 possibility. Khakis, white, and black, that's a 2nd possibility. Khakis, red, and white, 3rd. Khakis, red, and black, a 4th. Khakis, green, and white, okay, a 5th. Khakis, green, and black, a 6th. So we have 3 different pants, so 6 times 3 is a total of 18. We have a total of 18, okay, possibilities. You can take a look at that example. I know that's a little messy on the whiteboard, but you can take a look at that. It's a lot cleaner on the notes. So we have 18 possible outfits. Then I'm going to go ahead and give you a practice problem. On the next page, we will have the answer of the practice problem, in which you have to do the tree diagram, the different possibilities or combinations, and how many. So please try that on your own and then check it from the notes. Now we have something that we're going to kind of build off of. It can get very confusing, so just let's stay as simple as possible here. And what that is called the fundamental principle of counting. Now, with the fundamental principle of counting, we're actually going to focus on a 3-step process. And this 3-step process basically says that you are going to do the first step in a certain number of ways, the second step in a certain number of ways, and the third step in a certain number of ways. So because we don't know the number yet, we're going to say the first step is going to be represented by X. Okay, so X is kind of like that question mark, that first question mark. We don't know, okay, how many will be in that first step. Then we have the second step, and we're going to represent that by Y. We don't know how many will be in that second step, so we're just going to say Y. And then that third step, we're going to represent by Z. Okay, so we don't know how many is in each of those steps. Those are just questions. So we're going to go X, Y, and Z. Okay, so X, Y, and Z. So now, here's an example. Here's our first little example we're going to work with for X, Y, and Z. It says there are 3 choices. So let me just erase this. So we have X, Y, and Z. Remember, X is the first one. Okay, so in our example, we have 3 choices for the first letter. We have 3 choices. So for the first letter, which is X, we're going to have 3 different possibilities, 3 different choices. For the second letter, the second one, which is Y, we're going to have 2 choices. And then for the third letter, which is represented by Z, we're going to have 1 choice. So they are actually telling you what numbers are going to fit in those places. So for the first one, we have 3 choices. Second one, we have 2 choices. And the third one, we only have 1 choice for the third letter. So what we're going to do now is we're just going to multiply. 3 times 2, remember our rules. 3 times 2 is 6. 6 times 1 equals 6. That is the fundamental principle of counting. Let's take a look at another example. Okay, example 2. We have 3 choices of pants, 3 choices of shirts, and 2 choices of socks. But we have to, because we're doing the fundamental principle of counting, we're going to focus on, okay, our 1, 2, 3, our X, Y, Z. We're going to focus on our first choice, which is, okay, how many choices of pants? 3 choices of pants. Our second choice, okay, or our second object, which is shirts. How many choices? 3 choices of shirts. And then the third, which is Z, which represents socks, we're only going to have 2 choices. Now, this is going to be very different from using a tree diagram. Okay, this is basically the fundamental principle of counting. We're going to say that, so you're going to have to use this method. We're going to multiply. Remember, we're going to do these first. 3 times 3 is 9, times 2 equals 18. So for the different combinations of pants, shirts, and socks, we're going to have a total of 18. 18 different ones. Now, if they said in the practice problem, let's say they said for first choice, we only have 1. For second choice, we only have 2. And for third choice, we only have 1. Well, what we would do is we'd do the same thing. We'd just multiply, okay? 1 times 2 is 2, times 1, that gives us 2, okay? So you're just multiplying here. Okay, let's go to the third example. The third example, it says we have the arrangements of A, B, C, and if each of the letters can be repeated, okay, how many arrangements would I have? So we're still using this X, Y, Z pattern, and what we're going to do is, okay, for the first slot, okay, what can fit there? A can fit there, B can fit there, and C can fit there. So how many different possibilities? 3. A could have went there, B could have went there, C could have went there. Now let's look at the second choice. The Y slot. How many different possibilities? A can go there, B can go there, C can go there. 3 different possibilities. Now our third slot, the Z slot. How many different possibilities for A, B, C? A can go there, B can go there, C can go there. 3 different possibilities. So I'm doing 3 times 3 times 3. So this is going to be 9 times 3 equals 27. 27 different possibilities. Take a look at the notes. I have it a little cleaner and neater. Then on the next page, I have 3 practice problems with answers. Flip to the second page for the answers. And then I have 3 more practice problems. Try those. I really try to break it down and explain it for you and help you out in the word problems. So then you flip to the second page or the next page, and then you have the answers. So try those. Also try the textbook problems. There's 12 on there. You don't have to do all of them. Do them to help you. I would really encourage you. More practice is always beneficial, okay?